Hello everyone, this is my ninth lecture and in this we shall discuss about the few important questions on electric line of forces which we have studied in lecture number 8. I have selected some important questions which are frequently asked in the CBSE examination and the question number 1 is an electric field line is a continuous curve. That is, a field line cannot have sudden breaks. Why not? This is the question and the answer of this question is as follows. We know that if an electric field line has sudden break, that means at a finite distance the electric field intensity must be zero. And we know that electric field intensity at a certain distance E is equal to kq upon r square. And if r is infinite, then E will be zero. This is the only possible way that electric field intensity is zero, and the second possible way is Q is equal to zero. If an electric field line is present, that means Q never be zero. That means electric field intensity can only be zero when R is equal to infinite. Means electric field intensity cannot be zero at finite distance. That's why electric field line is always a continuous curve or it does not have any sudden break. This is the answer of the first question. Again I am repeating, E is equal to kq upon r square. If r is equal to infinite, then only E is equal to 0. This is the answer of the first question. Now the question number 2, explain why two field lines never cross each other at any point. This question we have discussed yesterday and now I am again repeating. If they do so, means field line crosses at a certain point, then we can draw two separate tangential lines at the point of intersection according to the separate field lines at a single point that shows the direction of electric field intensity at a single point. Two separate directions of electric field intensity at a single point shows that a charged particle can move along two separate directions at a single time from a point, and which is never possible. Again I am repeating, if electric field line crosses one another, then at the point of intersection two separate field lines can be drawn, or two separate tangential lines can be drawn that shows two separate directions of electric field intensity at a single point, and which is never possible. So this is the answer of the second question, and we have discussed this question in lecture number 8 also. Now we move to question number 3. What is question number 3? The question number 3 is this: draw the field lines for following cases. This question is also frequently asked in the CBSE examination, and the answer of this question is as follows. Third, the first is Q is greater than 0. If charge is greater than 0, that means the charge must be positive. And for positive charge body, we can draw the electric line of forces along outward direction. And this is the shape of the field lines. Q is greater than 0 means that Q must be positive charge, and from positive charge field lines move away. So this is the answer. answer of the second part of the question is Q is less than 0. Q is less than 0 means the charge Q is negative, and for negative charge field lines move towards the charge body, and the direction of field lines can be drawn just as follows, and this is the direction of field lines. So this is the answer of the second. Q is less than 0. Q is less than 0 means negative charge. Q is greater than 0 means positive charge. From positive charge, field lines move away, and for negative charge, field lines towards the charge body. The third is two positive or negative charges are placed close to one another. This is the answer of the third part of the question. Number third is this, that the two positive charges, this is positive charge, this is positive charge, and field lines means positive charge, the imaginary part of positive charge, and it is move and repel in this direction, it is move and repel in this direction, this is move and repel in this direction, this is move and repel in this direction. Then after this one, then 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 this one, and this is the directions. Again for this charge, they are moving away. And we can draw the directions, and it is asked in 1 mark question. And if two negative charges are separated by a close distance, then the shape of the field lines are same, just like that. For this it is also but the directions will be towards the charged body or charged particle. So this is the answer of fourth question. If two positive or negative charges are separated or placed very close to one another, then the shape of the field lines is this. And then the fourth one is electric dipole. What is electric dipole? If a positive and negative charges are placed very close to one another. This is positive charge and this is negative charge, and if they are equal in magnitude and opposite in nature, means positive and negative charges are placed very close to one another, then they form a dipole. And electric line of forces always moves from positive to negative charge. This time and this is. They are moving from positive to negative, this one also, this one also, and again they moves. We can draw as many lines as we can. This. Again for this. Towards the negative charge. towards the negative charge. So the shape of an electric field lines in an electric dipole is they are moving from positive to negative, positive to negative, positive to negative, and here all the field lines are moving towards the negative and all field lines moving towards the positive charge. And the last and final shape of field line is uniform electric field. We know that electric field lines comes closer in greater electric field and field lines move away from one another or repelled in lesser electric field. That means in uniform electric field, the electric field intensity is same or equal, so the separation of the field lines never be changed and the field lines are parallel to one another for uniform electric field. Again, I am repeating, electric field intensity is equal at all points in uniform electric field, so the separation of the field lines never changes at any places and the field lines becomes parallel to one another and the shape of the field line is parallel pattern of the field lines. This is the answer of the question number 4. Now we shall discuss about the question number, this is the answer of question number 3. Now we shall discuss about the question number 4. Answer of question number 4. This is the pattern given to us. We can draw more lines if we want. And here is the point A and here is the point B. And we are asked which one is greater. EA means electric field intensity at point A or EB means electric field intensity at point B. So in this case, we know that here the electric field lines are at more more separation and here is the separation of field lines is smaller. So the density of field line at this point or at point A is smaller. So electric field intensity will also be smaller. Here the electric field lines are closer to one another. So the electric field density of field line is greater at this point and the electric field intensity will also be greater. So in this case, EA is less than EB because field lines at point A, field lines at point A are farther, so density of field line, density means number of lines per unit volume, so the density of field lines is smaller and electric field intensity at this point is also smaller. Similarly, at point B, the field lines are closer to one another, so the density of field lines is greater, so electric field intensity is also greater at point B. Field lines at point B are closer, so density of field lines means number of field lines per unit volume, so density of field lines is greater, and electric field intensity at this point is also greater. So at this point the field lines are farther from one another, so density is smaller, so electric field intensity is also smaller. At this point the field lines are closer to one another, so density is also greater, and the electric field intensity is also greater at this point. Now we shall discuss about the question number 5. Which of the following cannot possibly represent a field line? So we have discussed about the characteristics of field line, and here is the curve is given to a charged body, positively charged body is given to us, and we have studied that the field lines are always perpendicular to the surface of charged conductor, whether it is positive or negative. So the field line must be perpendicular, but here you can see that the field lines are not perpendicular to this charged conductor, so this is not possible. Because field lines are not perpendicular to the surface of this charged conductor, so it is not possible. For the second case or the second figure, the field lines are moving from positive to negative, no doubt about that. But in this case, the field lines are moving from this negative charge to this positive charge. Field lines are moving from this positive charge to this negative charge to this positive charge, and in this case the field lines are moving from positive to positive, which is not possible because field line always move from positive to negative. They starts from positive charge and ends up at the negative charge. So in this case, here is the correct, but the field lines are moving from negative to positive and positive to positive, which is not possible. So this is also not possible. Now the shape of the curve is given to us. Third figure is given to us. Here are the positive charge. This is also positive charge. This is also positive charge. And in this case, the field lines are crosses one another. And we know that electric field lines never cross each other. And here the field line crosses one another. So this figure is also not possible. For the figure number 4, the two charge bodies, positive and negative charge bodies, are placed to one another. Here are the field lines are moving from positive to negative. The field lines are moving from towards the negative charge, and here is the moving away from the positive charge. But some field lines are closed. And electric field lines never be a closed curve. They start from positive charge and ends up at the negative charge. So field line never be closed curve. So this is also not possible. Again, we can explain it that these are the charge bodies and the field lines are always perpendicular to the charge body. So we can explain by this also, or we can understand this fact by this also. And here the electric field lines are closed curve. This is not possible. So this curve is also not possible, and the figure number 5 is given to us. Here the positive charge is moving away from this and positive charge moving away from this, and the pattern is also same. As the positive charge of field line is moving, then it is repelled, so it moves away, here if the field lines are moving away. So the shape of the curve, this is the correct. So this is wrong because electric field lines are not perpendicular. This is wrong because field lines never move from negative to positive or positive to positive. But this is wrong because field lines never cross each other. This is the wrong because field lines never be close each other and never be close. And here is this is the correct answer. So these are the few important questions which we have.